reduce the given quadratic form into canonical form by orthogonalization. Okay, so is it visible, my letters?
Yes, ma'am.
Okay, the first quadratic form, write down x1 square plus 3x2 square plus 3x3 square minus 2x2 x3 minus 2x2 x3. Say this is a quadratic form, right? Okay, go through the procedure. Already I given the procedure, no? Now, then go for the first step. What is the step 1? Change the quadratic
Find the
form into the...
eigenvalues.
No. That is the second step for this method. First of all, we need to write the matrix of the given quadratic form. Okay. So, how many variables in this? x1, x2, x3. Again, x1, x2, x3. Here, x1 square coefficient 1, x2 square coefficient is the 3, x3 square coefficient is the 3. And x2, x3 minus 2 by 2, that is the minus 1 or minus 2 by 2, and which is equals to x3, x2 minus 2 by 2. Remaining all are zeros. x1, x2 coefficient is not there. x1, x3 not there. So remaining. Now, what is the given matrix here? 1, 0, 0, 0, 3, minus 1, 0, minus 1, 3. So, this is the matrix. Clear? Now, go for the step 2. Now, what is the step 2 here? In the chapter. Then, what is the step 2? Finding the eigenvalues.
Find the eigenvalues.
To find eigenvalues. Basic procedures. We are going to find the eigenvalues. The characteristic equation is det of A minus lambda I equals to 0. See, this is a matrix now. This is a given matrix. For this matrix, we are going to find the eigenvalues, right? First of all, write the characteristic equation. 1 minus lambda, 0, 0. And 0, 3 minus lambda, minus 1, minus 1. And here 0, minus 1, just this is a 3 minus lambda. And is equals to 0. By the simplification, I am getting the eigenvalues. The eigenvalues basic procedure you are going to find, and we have to solve. The eigenvalues are 1, 2 and 4. How many eigenvalues here? 4, 3. Then go for the step 3. What is step 3? Find eigenvectors. Are you clear? Now, the eigenvector capital X equals to x1, x2, x3, which corresponds to lambda is A minus lambda I into x equals to 0. Just write the characteristic polynomial matrix. Characteristic matrix. Is it clear? So that is given by 1 minus lambda, 0, 0, 0, 3 minus lambda, minus 1, 0, minus 1, 3 minus lambda into x1, x2, x3. That is equals to 0. See, this is equation number 1. Completed all? Any doubts more?
No, ma'am.
x3 x2
Next.
coefficients ఎలా రాసింది?
Huh?
x3 x2 minus 2 by 2 రాశారు కదా, ఎలా రాశారు?
లాస్ట్ క్లాస్ లో చెప్పాను కదమ్మా, ప్రోడక్ట్ టర్మ్స్ వి హ్యావ్ దట్ కోఎఫిషియంట్ ఈస్ డివైడ్ విత్ ద 2. లాస్ట్ క్లాస్ absent అయ్యో.
ఓకే మ్యామ్.
Product term
Minus
coefficient is divide with the 2 only, and this is equals to this one, x2 x3 equals to x3 x2, and
లేదు మ్యామ్,
squaring terms coefficient as it is we are going to write, product term coefficient we are going to divide with the 2.
ఓకే మ్యామ్.
Okay, next,
Okay.
how many eigenvalues we have? 3 eigenvalues total. We have the 3 cases. Clear? Now go through the cases. The case 1 corresponding to lambda equals to 1. Okay, and in equation number 1 put lambda equals to 1 in equation number 1 is implies that here this is the equation number 1, 1 minus 1 0 0 0 and 0, 3 minus 1 is the 2, again minus 1, 0 minus 1, 3 minus lambda, this is 3 minus lambda means that is also 2, and see into x1 x2 x3 which is equals to zeros. Clearly we go for the substitution method because of one of the row is complete 0 and remaining 2 rows having only the 4 variables. But in this case also I am going to selecting the last 2 rows for using the cross multiplication method. Is there applicable? So that is 4 variables are minimum, that is 0 2 minus 1 0 minus 1 2, again this 0 is repeated. For the simplification, x1 by 4 minus 1 is the 3 and x2 by 0 and x3 by 0, then the first eigenvector is 3 0 0. So that can be written as here 3 1s are 0 0, and that is x1 equals to 1 0 0. Are you clear?
Yes, ma'am.
1 0 0. Next we are going to find what more? Normalized value. What is a normalized value? So that is equals to under root of 1 square plus 0 square plus 0 square. So that is equals to 1 only. So that normalized eigenvector norm x1 which is equals to each and every value in the eigenvector is divided with the 1. Again 1 by 1 is a 1, 0 by 1 is a 0, 0 by 1 is a 0. So the first normalized eigenvector is what more? 1 0 0. Are you clear?
Yes, ma'am.
Complete problem is visible?
Yes, ma'am.
Next, shall I rub the first part? Okay. Shall I rub?
Okay, ma'am.
Next. Then go for the case 2, which corresponding to lambda equals to 2. Are you clear? The second eigenvalue is the 2. The first one completed. Then go for the 4. First go for the second eigenvalue and put lambda equals to 2 in equation number 1. That is implies that here this is the equation number 1. 1 minus 2 is the minus 1 0 0. 0, 3 minus 2 is the 1, again minus 1. 0 minus 1, 3 minus 1 is the 2. 3 minus 2 is the 1. Are you clear? Into x1, x2, x3, which is equals to zeros. Okay, ma. Now in this case, we go for the substitution method. First of all, we have to multiply here minus x1 equals to 0. That is x1 equals to 0. And these two are the identical. See how I am getting here x2 minus x3 equals to 0. And this is minus x2 plus x3 equals to 0. Can be written as x2 minus x3 equals to 0. Is it clear? Are you clear, ma? Now,
Yes, ma'am.
these two are the same. So, by the simplification, what we get here, x2 equals to x3 and x2 by 1 and x3 by 1. Therefore, x2 eigenvector is x1 0, x2, x3 1 1. And the normalized value, what is the normalized value? Under root of 0 plus 1 square plus 1 square. So that is equals to root 2. It is clear? Therefore, normalized eigenvector. What is a normalized eigenvector? Each and every value in the eigenvector is divided with the normalized value. So that is 0, 1 by root 2, 1 by root 2. Okay? Which is denoted by norm x2. Second eigenvector, that is the normalized eigenvector completed. Tell me.
X1 value is correct in a ma'am. What
x1 is the 0.
Yes, 1 ma'am.
Minus x. Huh? Case 1.
Yes, 1.
Correct, ma? 4 minus 1 is the 3. And x2, 0 minus 0. x3, 0 minus 0 again 0. 1, 0, 0.
4,
3 1s are 3.
4 plus 1 ma'am.
ఇక్కడ ప్లస్
Okay, ma'am.
ఇది 4. ఇది ప్లస్ అవుతుంది, ఆల్రెడీ మైనస్ ఉంటుంది. 4 minus 1 is the 3. Second eigenvector, normalized eigenvector completed, ma. Now go for the case 3. Then what is the case 3? Corresponds to lambda equals to 4. Is it clear? Put lambda equals to 4 in equation number 1. Then 1 is implies that. Shall I rub the step 2? Shall I rub the step 2?
Yes, ma'am.
What, ma?
మేము అది x1 ఎలా కట్ చేశారు మేము? ఒకటే 3 ఉంది కదా.
అవును, ఒకటే 3 ఉంది. 3 1s are 3. 3 zeros are 0. 3 zeros are 0.
ఓకే.
Next one is implies that lambda equals to 4, ma. 1 minus 4 is the minus 3, 0, 0. Second row, 0, 3 minus 4 is the minus 1, and that is minus 1. 0, minus 1, 3 minus 4 is the minus 1. Into xyz, which is equals to zeros. Now again, which method we are going to use?
1 x2 x.
Which method we are going to use? Substitution method or
Substitution
cross
method.
multiplication? Substitution
Substitution
method
method.
only.
Substitution.
Because these, very good. These two are the identical rows. Then first one is what here? X1, x2 and x3. So minus 3x1 equals to 0. Clearly x1 is the 0. Then these two are the same. Minus x2 minus x3 equals to 0. Again minus x2 minus x3 equals to 0. By using this, what we are going to write?
Minus x2 is equals to
Minus x2
x3.
equals to x3,
x3.
right? x2 by minus 1 or x2 by 1 and x3 by minus 1 cross multiplication. Is it clear? Therefore, x3 equals to eigenvector 0, 1, minus 1. Clear all of you? 0, 1, minus 1. Normalized value. Normalized value, that is under root of 0 plus 1 plus minus 1 whole square is also 1. So that is also root 2. Therefore, normalized vector, normalized eigenvector, norm x3. So that is equals to 0, 1 by root 2 minus 1 by root 2. All the three normalized eigenvectors completed. The step 3 completed. Is it clear? Then go for the step 4. Then go for the step 4. Then what is the step 4?
Model matrix and diagonalization.
Model matrix and diagonal matrix we are going to write. The model matrix, capital P. So capital P equals to norm x1, norm x2, norm x3. So capital P equals to, just to substitute the vectors. What is x1 normalized eigenvector? 1, 0, 0, right? And the second one, here this is
0,
0, 1 by root 2, 1 by root 2. Third one, this is 0, 1 by root 2, minus 1 by root 2. Now, and diagonal, capital D equals to diagonal elements. The diagonal elements are eigenvalues. Okay, now 1, 2, 4. So the matrix formed by 1, 0, 0, 0, 2, 0, 0, 0, 4, which is the diagonal matrix. Are you clear? Next, then go for the step 5. Then what is step 5? Tell me. Finding the P inverse.
P inverse.
Okay, but what is the result without using the formula of P inverse? Since P is orthogonal, then write down P inverse equals to P transpose. Okay, now? Now we are going to check capital P is orthogonal or not. Shall I rub the case too?
Yes, ma'am.
Definition of orthogonal, that is P into P transpose equals to I. Just we are going to check it out. Capital P matrix already we have, that is 1, 0, 0, 0, 1 by root 2, 1 by root 2, 0, 1 by root 2, minus 1 by root 2. This is the capital P into P transpose, the transpose of this matrix. First column is the first row, 1, 0, 0. Second row is the second column is the second row. 0, 1 by root 2, 1 by root 2. Third column is the 0. That is row minus 1 by root 2. See here, the result. The result ultimately we are getting what ma? Identity. What is the identity matrix of order? This is a 3 by 3, this is a 3 by 3. The result matrix is also we get the 3 by 3. You can check, we are getting the orthogonal only. Okay, just we have to check it out. Here first row into first column, 1 into 1, plus 0, plus 0, 1 here. Okay, now next, first row with the second column. First row, second column, this element. We have to check 0, 0 and 0. This is the 0. And we have to check any element. So the third row with third column. Third row with third column. See 0 and minus 1 by root 2 into 1 by root 2. 1 by 2 plus again 1 by root 2 into 1 by root 2, that is the 1 by 2. 1 by 2 plus 1 by 2 is the 1. See, this is the 1. Are you clear? Compulsory, we are getting the orthogonal. There is no change at all. Okay now? Now, since P is orthogonal, therefore P is orthogonal. And P inverse is what now? P transpose. P inverse equals to transpose of P is this one here. 1 0 0 0 1 by root 2 1 by root 2 and 0 1 by root 2 minus 1 by root 2. The concept of the inverse is any doubts? Hello ma. Without using the
Yes,
inverse
ma'am.
formula adjoint and cofactors, we are getting the P inverse matrix using the orthogonal definition. P into P transpose equals to I. Directly we can write P inverse equals to P transpose. That one completed. Next, then go for the step 6. Then what is step 6? Step 6, checking the diagonalization. Check P inverse AP. Is capital D or not? Okay. Shall I rub this?
Yes, madam.
Now we have to check it out here. P inverse A into P. So that is equals to P inverse is this one 1 0 0 0 1 by root 2 1 by root 2 0 1 by root 2 minus 1 by root 2 into capital A. What is capital A ma? Capital A 1 0 0 0 3 minus 1 0 minus 1 3. Is it clear? That one only now.
Yes, ma'am.
Now into capital P, that is the capital P 1 0 0 0 1 by root 2 1 by root 2 0 1 by root 2 minus 1 by root 2. Then what we get ma? Product of three matrices, what we get? Tell me the matrix. Tell me the matrix only.
1 0 0
Diagonal matrix.
1 0 0 0 2
0
0
2 0
0
0
0
0
4. And this is the capital D. Therefore, hence P inverse AP equals to D using orthogonal. Okay, the problem is not completed. Last step. What is the last step? Step 7. We are going to write canonical form. Then the canonical form is what here? Y transpose
Transport
P
P inverse
inverse
AP into Y.
Y. Very good. And what is P inverse AP? D. P inverse AP equals to D. Right, all of you? So into capital Y, where capital Y equals to Y1, Y2, Y3 implies what is Y trans?
Ma'am, video.
Video is not.
Madam, video got paused, ma'am.
వీడియో రావట్లేదు మేడం.
Is it clear my video ma?
No, madam.
No.
It is clear now.
Yes, ma'am.
Yes,
ma'am.
Okay, ma'am.
Next, We are going to take assuming the capital Y matrix is y1, y2, y3. Immediately you are going to
Not
transpose.
coming, ma'am, video.
Is it visible, ma? All
Not
of you.
visible, ma'am.
Video is
It's
clear or
coming,
not?
ma'am. It is
Yes,
clear,
ma'am.
ma'am.
Yes, ma'am.
Have to check your proper signals. Now, capital Y equals to this and Y transpose is this one. Now, substitute Y transpose capital D and Y in the given formula. So that what we are getting here, Y transpose D into Y. Y transpose is here Y1, Y2, Y3 into capital D. Y transpose D into Y. So that is equals to here this is y1, y2, y3 and the capital D. Where is capital D here? This one 1 0 0 0 2 0 0 0 4 into capital Y is this one y1, y2, y3. Now first row with the first column. Just multiply, that is y1 only, plus 0, plus 0. First row with the second column, 2y2. And first row with the third column, 4y3. Into the column, y1, y2, y3. Again, first row with the first column. That gives only one element. That gives only one element. So that is y1 into y1 square, plus
Y1
2y2
square.
into y2. 2y2 square plus
Y,
4y3 into y3, y3
4y3
square.
square.
Therefore, canonical form y1 square plus 2y2 square plus 4y3 square. This is the problem. Completed, ma. Complete 15 marks. Each step minimum 2 to 3 marks. Each step. Seven twos are 14. 14. Each step is 2 marks. And the eigenvectors, normalized eigenvectors, step is 3 marks. 6 steps are 2 marks. Normalized eigenvector step is the 3 marks. Complete 15 marks. Are you clear? Any doubts?